Hey all, I'm going to show you how I built a solar water heater for our hot tub. The goal of the project was to reduce our energy use and carbon footprint while not making anything too ugly. Hot tubs use a lot of energy, but now our hot tub uses 90% less electricity on sunny days, which we get a lot of in California. This is my second attempt to make a solar water heater. First version was much smaller, and while it heated the hot tub well during the summer, it wasn't up to the job in the winter. The solar collector sits on top of this narrow cabinet which houses a water pump and two temperature controllers. One of the temperature controllers is for the hot tub and the other one is for the solar collector. When the hot tub is cooler than the set temperature and the solar collector is warmer, the pump turns on and circulates water from the hot tub through the solar collector and back. Now I'll get into some specifics. The solar collector consists of a 4-foot by 4-foot plywood sheet overlain with foil insulation and a black rubber sheet. About 200 feet of PEX tubing is coiled on top and held in place with metal hanger straps. I threw in a silica gel pack to reduce condensation inside, and then everything is covered with a plexiglass square. On top of that, I just put on a double paned window that was left over from the first version of this solar collector.
The PEX tubing is coiled into a counterflow spiral. This means that the coldest water coming into the solar collector runs next to the hottest water coming out, which allows for a very efficient transfer of heat.
The solar collector tilts, and this right angle piece of wood allows me to line the solar collector up with the sun. I adjust the angle of the solar collector about once a month. Here we can see inside our 200-gallon hot tub. The longer tube pulls water that's somewhat cooler from the bottom of the hot tub. The shorter tube discharges the heated water near the surface. You can also see the temperature probe for the Inkbird temperature controller that I'll show you in a second. This blue object is our saltwater chlorinator, which is fantastic, but is unrelated to the solar water heater project. The tubes run inside our spa cover lifter, which I made out of 2-inch PVC to accommodate the tubes, as well as some insulation that I injected. And down at the pivoting end of the lifter, the tubes are connected to shark bite connectors that swivel when the cover is opened.
So here we have two Inkbird temperature controllers. The one on the left measures the hot tub temperature. As long as the temperature is below 105 degrees, it powers the second temperature controller, which monitors the water in the solar collector. The probe for this controller is placed against a metal pipe coupling in the solar collector. When the temperature exceeds 118 degrees, it turns on the water pump. I can't show you the pump because it's sealed inside a lot of soundproofing, but it's a Seaflow 3 gallons per minute transfer pump. The temperature setting on the pump controller determines how often the pump turns on. At high settings, the pump comes on less frequently and stays on briefly. I've set this one to 118 degrees, which is enough to warm our hot tub from 99 to 105 degrees on a sunny day. We like to use our hot tub at night, and by that time the water generally has cooled to 104 degrees.
The soundproofing dampens the sound of the pump, but it's still a bit noisy. Closing the door, which also has insulation, dampens the noise further. The hot tub itself is plugged into a timer which comes on at 4 p.m. and turns off at 11 p.m. If the hot tub hasn't already reached 104 degrees, when it turns on at 4 p.m., the hot tub heats itself. I hope you found this video useful. If you have any questions, put them in the chat and I'll try to answer them. Thanks.